Thank you, Global PropTech, firstly, for inviting me in such a forum wherein I can talk about geospatial data for smart cities. Before not wasting time much on what actually is geospatial, let's go ahead talking about geospatial analytics. What are geospatial data? What is the functionality? And what are there used in the usage of smart cities? So when we talk about the main common analytical challenges that we all face, we basically talk about how the data is trying to fit up with the tools and system around us. How we integrate this kind of silhouette workflow and the systems to deliver the applications. What are the amazing geospatial visualization wherein we can actually get into the depth of what the data is all about, how it is visualized, in what way it's presented, and finally, in what perspective are we really looking for. We are accelerating the data science, and indeed, the geospatial data science is a very important part of smart cities. When we talk about smart city, we need to definitely focus on data because data is what makes a city smarter, workable, more digital. When I go into the depth of analytics and talking about the scale in what perspective we are working on, we definitely would like to talk on the big data. Big data, as the name suggests, is the data which is huge. We need to analyze it. We need to start streaming it all across. So the big data is basically talks about the four main basket of distribution, whether we talk about the streaming analytics. For example, I would say Twitter data, which talks about streaming of the data, interactive dashboards. So when I talk about interactive dashboards, definitely I would love to talk about the ad hoc analysis, how we are trying to interact and analyze each and every aspect of the interaction. The spatial thermal visualization that will be more on geospatial, and what kind of data science in order to what we have achieved this analytics. When we talk about this, there are few tools that we would like to go through, whether it's SQL, Python, R. In order to be a data scientist, we need to have the basic use of all this perspective. The next slide, I would say, will talk about the application of this geospatial data. So when we talk about the main application, I would say the first case will be the telco industry. So the telco industry, definitely we talk about the network reliability and design optimization. So design optimization would definitely talk about the mobile data offloading. When we talk about mobile data, we all should be very particular that our data is being tracked. It is being taken ahead, it is being captured, and you know what, the mobile data is used for prediction of various others activity, which we knowingly, unknowingly are sharing our personal data for people like data scientists to use it and try to predict the movements. So this is what I would say is network reliability. So when we go ahead with the customer experience, we would definitely talk about how we try to monitor this kind of network quality, how we predict the churn analysis. We would definitely like to talk about the 5G architecture, and finally how we try to roll out this kind of architecture. The next main use, I would say, is the telematic industry. The telematic industry, as you all must be aware and would be widely using, is about the traffic management and is about the route optimization. When I talk about the route optimization, basically I will try to use an algorithm in order to find the shortest path of the user from the origin to the destination. So the activity what a geospatial data will do, a geospatial data science will work on, is what is the shortest route? In what way are we trying to map the behavior of the driver? How we are trying to monitor their behavior? So this is the major use case as a geospatial in smart cities. When we talk about the vehicles, we would definitely talk about the driver's behavior. Whether it is nowadays, many people are coming up with driverless cars, or I would say autonomous vehicles, whether you name it Tesla or Uber, they're coming up with this kind of innovative technology. Why are we trying to use this technology? Because to make it more digitalized and to see how we can take the telematic industry to the next stage. If you see this example, wherein we see how the data is being captured in the small video, whether you are driving on the road, or when you're crossing the road as a pedestrian, or you're parking your vehicles in the parking layout, or you're just having a walk with your friends after or in between your office hours. Each and everything is mapped, whether it's a crowd flow management, a pedestrian movement analysis, how the parking layout, what is the public avenues, how the vehicle is detected and it is being tracked, and what is the flow management that is being observed. And the final use case, I would say, would be on smart meter. It should be definitely being concentrated of how the energy and utility industry plays a major role in metering, because it reduces the fraud and leakage. It tracks the customer usage. It definitely monitors the distribution of metering. When we talk about smart meter, we would definitely talk about the LiDAR data, which is available on the satellite mapping. When we talk about the density mapping, we would like to talk about the oil and gas analytics. I would like to show you all this geospatial, which is the fuel of today's data world. It's all about spatial data. So with that, I would like to show you a small demo wherein you yourself will try to understand how we are trying to demosize the data and try to figure out. So this information is being taken by Omni Sky, which has created this dashboard for Hong Kong consolidated view. Now, if you see a dashboard wherein on the left, on my left side, I would try to see the data in 4 perspectives. One is the CSR data, which is located of Hong Kong. Then comes the Twitter data, which is mapped according to what actually it's available. Then come the history backup summary data, in what perspective we are trying to see the spread of the data. And finally comes the crowdsourcing data. So in this dashboard, if you notice how my data is being distributed, how in Hong Kong, a country like a Hong Kong, and you have the distribution of the data, what time of the data, what are the rates, how are the devices that is being tracked, what is the recording time that is being calculated and presented in this dashboard. And with this data, I would tell you as a data scientist, we have a lot of advantage in order to take this data and predict the movement of the users. Definitely, with the number of devices and with the number of presentation, we would try to understand what is the rate of movement, what is the latency, how the rates, what is the timeline that is being tracked. So if you see, there are small panels that's been created, and there's a geospatial view of Hong Kong. It's a map which shows, if I click on the user, you can see how the data shows where the user is available, at what time, and how the data shows the radius and the ID of the user's mobile phone. So this is how the data of Hong Kong is being visualized. And if just imagine, if I just click on any of the data to see what is the stats that I would like to recognize, I will just click, I would see the gradation of what range it is available. And on the right side, you will be able to see my representation, what is the duration of how long that user was available in that location. What is the output? What time of the day was he available? And with that technology, we would try to understand in more further detail of how geospatial data would massively use and how it can be used in various perspectives, whether it could be from SQL or whether from the normal database. This visualization of how the data is represented is important for any data science to proceed with the analysis. So if you come up here in this example, I would like to concentrate, if you see in USA. Now, if you see on the left side, you can see how my latitudes and longitudes is spread across the place. And if I want to zoom in and want to buffer one zone, like for example, if I would like to buffer Beverly Hills in Los Angeles, I would just select the portion and I would say how many users are available. What is the timeline? What is the trips? What are the miles driven? What is the collision that is being observed? How are the correlationship between each and every latitude and longitude is mapped? I could move my squares and see the differences. So when we come up with this stage, what are we trying to do? We basically try to see what is geospatial. We are trying to have few hashtags like polygons, geography, geometry, k-means. This is what it's all about. It's very important to know the geometry of the space that you're working on. Basically, that will be represented as a coordinates. Whether it is as a spatial object, it needs to be represented in a Cartesian plane. So when the calculations are done, it is required for you to project it on the plane in order to see which location are you located. And that works when the geography of the location is being defined. For example, in UK, I would say WGS84 is the coordinate system and where my latitude and longitude is lying and how I'm able to measure the degree in my perspective. Definitely, when we go into the details, what are the main spatial classes? It's as simple as having points with X and Y, having multi-points with various attributes, whether it's X01 or Y01, the line strings that has been aligned, what are the multi-line strings, and finally, what are the polygon that is being created. So the main four elements, I would say, in this study would be how the data needs to be integrated. So the first point is when our today's infrastructure is being talked about tomorrow's technology, how we are trying to potentially use this kind of data. We will try to verify the data which is more accurate and consistent and how we could complete the decision making. Definitely, we would try to use location mapping. We would try to analyze each and every aspect and how we are going to drive this into a superior outcome. Finally, we are going to enrich it with a decision of prediction and what is the algorithm that we have used. Definitely, this kind of spatial processing reduces the LI, which is lesser than 90%. Data science, artificial intelligence, machine learning, IoT, these are the main things that I would say can be used for a data scientist, which is much greater than 80%. What are we really talking about? We are talking about how to address the data. What are the large-scale geospatial data and what is the location data quality that we are achieving? Now let's come up to a slide wherein we try to map what are the smart cities around the world and where as a country that we all stand. So first is South Korea. So Seoul is the one which could be rated as a smart city. Then comes Germany and finally the Singapore, and the list goes on. We need to all work across to make a city smart with various other technologies. And I would say geospatial data is the main source of making a city smart. Now, there's various studies that have come, and most of them says that is only 33% of data science have been seen successful. So with more findings, more data mugging, there is a lot of hard work involved. And finally, we need to see how successful we are to achieve this. Now, when we talk about location intelligence, we need to quickly see what are the millions of customer records that has been achieved. How are we trying to integrate the value, the intelligence information, which is good or bad, it is definitely important for us to understand how the big data and the cloud technology is being used and what is the geo enrichment that we are going through. So as a smart city, we need to have this kind of data science project which minimizes the cost and definitely have a better technology free country. I would also like to tell you, location intelligence is some of the insight wherein most of the management, visualization, and data analytics plays a major role. It should be definitely used in most of the maps that I had shown a demo on. It requires a dashboard which needs to be interactive so that your data is represented. It needs to be interactive, definitely. And finally, how the supervised learning can make it a proper, more data analytical world. It needs to be having more of an operation use, because the large amount of data, the more of data analytics, because it's not easy to review your data in an unsupervision in order to have a geo enrichment seen in the data. Finally, when we try to unlock these locations, we try to see what we can do without or with using the maps. And when we come up with this stage, we have 4 main sectors that we talk about business insight. Firstly, we need to talk about the operation. Second is we need to see how the location data can be used to automatic world. In what way are we addressing the geocoded position? Can we input the data in order to have a spatial information? In what way are we saving the time in order to have a map analysis? So I would say the 4 main keys of a geo enrichment would be location, where you are located, what are your latitudes and longitudes, in what features are we like to be selected, whether it's a point, it's a line, or it's an area. So you will try to be more spatial object oriented. What kind of data extraction you will be learning, whether it's an attributes, the distance, the calculation, and finally the comparison. What are the business insights that you would be going ahead with, whether it's too risky or whether you would try to have the model, whether you will have the artificial intelligence and machine learning being represented. So whatever I've just explained, I have tried to provide it in each and every slide to make it more specific. And finally, all the coding will be available in the GitHub and various other sources wherein it can be shared. So when we talk about smart cities, we talk about 8 main sectors, whether it's admin, it's safety, it's transportation, economy, smart energy, health, and welfare. So geospatial data, it is not something it's new or it's just emerged. It was very much there from 1980s, and now we have it more device centric. It is there in our hands. So this is how the geospatial data has been emerged. I would like you all to concentrate on this study of smart cities framework, wherein you see how the economy, that is the cost performance and jobs and cost of living, has been increased because of smart cities. What kind of environment has been taken care, whether it's natural resources or energy, how the environment factor, what kind of quality are we trying to achieve? What are the society and the accidental disasters that we are going through? The health concern, I think after COVID-19, we all are concerned about our health. We need to have a better health facility. We need to see how and where we all as a society can be more safer and more connected. The governments, definitely the participation in decision making, the community involvement needs to be a criteria for smart cities development. The mobility of how safe your transport system is, how convenient and time efficient it is. We need to satisfy all these kinds of dimensions. And finally, at what propagation are we achieving? Is it scalable or is it what we achieve? So this has been taken from the Smart Cities of European website, and the study has been done by OECD elaboration. So when I talk about smart cities and I talk about sensors and cloud service, this is where the data is being considered, whether it's a smart grid, or whether I talk about an intelligent city, or when I talk about an intelligent hospital, we talk about hospital optimization. We definitely go in depth of the how we have the management picture. What are the logistics? What are the traffic flows that is taken care? How is the safety being measured? What kind of car system is being observed? What is the digital signage that is being connected? Now, I would like you to please concentrate on this slide wherein we show you the progress about how the country has been seeing the development and focus on smart cities. I would like to give an example of Glasgow because UK is where I've done my post-graduation on smart cities and urban analytics, definitely from UCL. Glasgow is being regarded in 2013 as a smart city. The reasons below mentions about the intelligence operation platform, how it analyzes the real-time data via online dashboards, smartphones, and visualizations. There are a lot or many hackathons that is being built not only for the students, for the working profession, in order to have the emergency service mapped. There are street lightings that is being considered on the streets to measure the air pollution, the lighting levels, and the footfall. So definitely, when you're in trouble, it can be detected. So this is some of the importance that Glasgow as a country has come up with. Smart cities initiative. If I talk about Spain, I would definitely talk about the sensors that are used in the buildings every 33 meters, how we are trying to monitor the temperature. What is the carbon noise and the light is being generated? What kind of irrigation system are we seeing in the parks and gardens, and what kind of rainfall is being observed in order to save money and water? Definitely here, the police officers were belted with sensors to identify the dangerous gases in order to give an emergency button to the officers to make a more initiative. Now, when I talk about China, India, and various other countries, there is a lot of development coming up in smart cities, and I would say geospatial data will be definitely one of the important source of development. So I hope I'm not exceeding my time. I will just through my slides talking about Singapore, Jakarta smart cities. I would like to give an example in India, wherein in India, Bangalore, they have created Cisco Smart City, which is replica of USA Smart City for Cisco. So this is how 2.1 million square foot of smart campus in Bangalore has been designed. So this is a smart campus that my colleague from RSP had shared with me, and he tried to identify how digitally they were connected and what kind of sustainable environment we tried to build. So this I tried to show you how the geospatial was an example for playing golf players in Canada, and how we use the algorithm to calculate the density of the mobile calls with regard to the location. So we started with data exploration and preparation of how we understand the data, how we feature engineer it, and finally, what is the recommendation. So we started with the Canada data. We tried to see what are the parameters that's available in Canada, what are the tables, what are the location. We went ahead preparing the location mapping. We tried to see what is the spatial objects we find. So here we found polygons. We took about the points. We tried to see the clustering method. Then we went ahead with data exploration. We used Python, a programming tool, in order to see how we are analyzing our data with the help of the timestamp, the parameters, the distance of the golf players. So with that, we went ahead questioning what actually we are trying to identify. We are trying to map the UTC. We are trying to see how the data is and what we are trying to achieve. The next task was solving the problem, whether the user location and the golf location was mapped, and what is the findings that we come up with the golf. So when we come up with the location, we go into the details about what are the latitudes and longitudes. How are we trying to find the location? Then we go into the 4 main steps of location, whether we start with summing and counting of the data, or we go ahead using a where and while loop to identify what function we need to define. And finally, we come up with a variable in order to get the location. We come up with a conclusion of having an elbow 2 and creating 2 clusters of golf players in Canada. And we also try to come up with a conclusion at what range about 3.7 million users are using more than 10 pings. So this is what our prediction came with our study. So to go ahead with what actually is a geospatial data, I would say geospatial data is nothing about the data which is spatially available. And it is operated with 2 main programming language like Python and R, and also a platform like QGIS and ArcGIS, which is readily available. So this is one of the map wherein UCL, my professor, had shared. When we talk about the geographic, we talk about the spatial analytics, we talk about the subset of spatial, that is the geospatial data. So this is what I have taken from one of the recording wherein you can see how the data is being mapped throughout the day, how the users are communicating, and what is the location mapping, what time of day it is, and where you can see clusters wherein you can raise an alert. We can raise an alarm to solve the problem in that particular area. So with that, I would say GIS or geospatial data science is nothing but a scientific method to solve a problem, to come up with a solution, only to have a resolution for smart cities. So when we go ahead, if we talk about the raw data, we talk about the evidence, we have the knowledge with us, and we go ahead with wisdom. So when I conclude my slide, we have a lot of data, we have a lot of advanced technologies, we have to see how the visualization techniques are being generated. When we have a larger community, we try to solve it with various spatial problems, and finally, this problems needs to be addressed. But definitely, this is not something new. This was solved 150 years before by John Snow, and now we all are putting our eyes on smart cities. So with that, I would like to conclude. I'm really happy to receive questions. Thank you.
Wow, thank you very much. That was so. I have a question for you. Can you give me an example of a city in the world where you think, well, they are really doing an amazing job with their data?
Sure. I won't be biased, because if I name countries like Singapore, because Singapore, I think it's best for the healthcare center. They are doing a really, really good job. I would say Singapore is an example for other countries in the healthcare industry, wherein how the doctors, how the patients are communicating digitally, and it's getting much more resolved and making ease of living much more easier and digital. Now, if I talk about Seoul, or if I talk about the task of how they are controlling the carbon content, if you see in other countries. So each country is unique as a whole. What I would say, we need to take the unique characters and try to incorporate in our city or country so that we make a better smart city. As I told you, we have 8 parameters of the smart city. So all the 8 parameters will vary from each and every city. And definitely it has both positive and negative involved with it.
And how can we learn from these cities from all over the world? Is there a kind of like a platform where knowledge is being shared already?
Yes. So that is where I think I would say thanks to you and the places where we all learn each other with our life experience. Okay, this is what we have learned with geospatial in that particular country. Why don't we consider in our country? If, for example, if I would like to take the technology to India, I would have a lot of process and lot of government approvals required, which will definitely take time, but it would be much easier if I could have developed in London, because definitely there is a lot of less restrictions what's actually there in India.
Okay.
So it depends, I would say.
It depends. Well, thank you very much for being with us today. Maybe we can go to the sessions and see if there are some people there that would like to have a short chat with you. But thank you very much for this amazing talk. I hope to see you soon.
Sure. Thank you so much for having me here.
Thank you.
Bye.
Bye-bye.